So just to frame this, you may have heard of the triple planetary crisis. Welcome to the 21st century. This is the UN Environment Program folks put together this framework, 3 prongs. You know, I don't really like this framework, but I want you to hear about it because you're going to hear more about it. There have been various variations, but this is the original. Here's why I don't like this framework. It obscures the relationship between these 3 elements. One element here is not like the other. One element is the cause of the others. So the elements have a specific relationship to each other. They're not really similarly situated like apples, oranges, bananas. Pollution is the cause of climate and biodiversity collapses. So pollution, as you know, comes in many forms. There's air, water, soil pollutants, and many types. CO2, greenhouse gases is a type. Chemical pollution, plastic pollution. We're going to learn that plastic pollution is a solid form of greenhouse gas pollution, and it's a solid form of chemical pollution. So why are these elements set out as though they're like similarly situated, like 3 equal tongs on a fork? Well, it's because nobody wants to point a finger at the cause of pollution, which we know is our economic system. And that's a construct, it's a choice, and we can choose to organize differently. So I have nothing against capitalism. It's a super efficient system for producing goods and services. I've personally benefited, but there's a problem here. The system that was designed to serve us, to help us meet our basic needs, that system is destroying us, and we've become captive to it. So we live to serve the system that should be serving us. And we can change that. In fact, we owe it to our children to change it. And I'm going to help you get started. First, I want you to see our movie. Why? Because it's an awesome tool for change. It's award-winning, but more importantly, student-led. It's extremely charming and very uplifting. So this movie is a brainchild of my dear friend, Cafeteria Culture founder and executive director, Debbie Lee Cohen, and our media director, Atsuko Quirk. It was released in 2019. It's a true story of 56 fifth graders in Brooklyn, New York, who studied plastics for 2 years and were charged to come up with some solutions. So if you didn't receive a link for this movie from George, you can grab it now. Just aim your phone's camera at the QR code and you can grab it. So let's look a little more closely at plastics and how it fuels this environmental collapse and directly threatens our health. I always like to start with the rivers, and we're going to go to Missouri first, really big river, right? But I want you to see this. So this is a trash boom these folks put in a stream in a city park, and it's collecting the plastics that are just floating on the surface of the water to catch them before they get downstream, which would be, right, going into the Mississippi and then out to the Gulf and the Atlantic and then over here to the Pacific, because we really just have one big ocean. It's all connected. So you can see this was in a city park because of the balls, right? And how long do you think this was there? Any suggestions? Put them in the chat. How long do you think this boom was in place in the stream? So I'm going to tell you it was there for only 2 days. So and I want to be clear, this is not a Missouri problem. I just showed this slide. I gave this talk to some the green team students in Oregon, and they're like rolling their eyes and they're like, hey, we're way too cool out here on the West Coast. This would never happen in Oregon, but I want to show you that it would. And it's same in California. I know you guys are very cool, environmentally aware, but this would happen in California as well. And the reason is most of this stuff is not littered. It's not intentional. This is a sign of a world overflowing with plastics. This stuff was likely left on a picnic table or on the ground or came from an overflowing trash can, then blown or washed into the river. Just a close-up, you can see how much of this is single-use plastics, almost all of it, and how much is connected with food and drink. And again, another part of the Missouri River, same thing. So our world, again, is overflowing with plastics. And our plastics are ending up in the global south. So this is one of Oh, I'm going to go back. Sorry, we won't get there yet. So why is our world overflowing with plastics? Because we're making so much of it. 500 million tons each year. Most of this is single-use plastic, foodware, and packaging. And that's great news, actually, because most of those are unnecessary plastics, and so a lot of opportunity. And if the plastic industry has its way, the production will double by 2040. I'm skipping. Oh yeah, no, that's right. So cafeteria culture focuses on school cafeterias, and why is that? As I mentioned, you've got in California, you have designated funding for your schools to install dishwashers and build up other infrastructures. So what happened, I hope Assemblyperson Holden was clear. Yes, the governor vetoed the bill, the specific bill that designated grant funding for schools in California to install dishwashers, which is part of the problem. But instead, he designated funding in his budget for that. There's just a different way to get. And to that money, we'll talk about it in a few minutes. But why are we focused on school cafeterias? Schools annually serve 7.35 billion meals. Each one of those meals, it's not uncommon to see 10 or more single-use plastics. This looks a lot different from when I went to school. Let's count them. We're going to go from left to right, starting with the Capri Sun. I give you just a second to kind of screen here and see if you can identify the single-use plastics in this photograph. Give you just a second to scan, and then we'll count them together. So we start with the Capri Sun pouch. Then there's the straw. We have the applesauce container, and this is typical in school lunches. We have the lid. It looks like foil, but the underside's plastic lining. We have the Twix candy bar wrapper. Again, it looks like foil, but it's not. It's layered foil material with plastics. We have condiment packets, which are rampant in school cafeterias. We have the maple syrup container, plus now you know the lid looks like foil, but with a plastic lining. We have the boat, looks like paper, but lined with plastic. We have the plastic fork. We have the Doritos. We have the package of utensils, which is in plastic packaging, and then we have the utensils themselves. We have the juice box with the plastic straw, but of course the straw comes in a plastic wrapper. And there's one more item here. I don't know if you found it. It's the tray. This is the so-called compostable plastic. It doesn't really compost, and I don't have time to go through it today, but I'm happy to answer questions or send you some more information. These compostable trays are composed of the same toxic chemicals that plastic is made of. It's probably no surprise to you, we are the world's biggest plastic user per capita, and we are the biggest plastic waste producer. As I wanted to say before, our plastics end up in the global south. Those are countries below the equator. And you know that, you've seen these photos. But I want to be clear, these are our plastics. And I was about to say before, it's one of my pet peeves. You read these articles about how most of the plastics, ocean plastics, are coming out of rivers in Asia and Africa, but those are our plastics. How do they get there? Well, we export them to those countries. Those plastics that you're putting in the recycle bins, or you think they're being sent for recycling, they actually are exported to these countries. And because there's no way to manage used plastics, and I'm going to tell you, explain why that is, they escape to the environment. I want to introduce you to this classic 2017 study done by the scientists Geyer, Jen Beck, and Lavender Law. They set out to answer the question, hey, what's happened to all these plastics that have been produced? Most of them since in 1950, they were used before that, but in 1950, they really started being cranked up, but have accelerated. The production has accelerated since the year 2000. And here's what they found. And we will go through this a little bit later. But first, let's get to plastic. If there's one thing I want you to take home from this presentation, this is it. Plastic is a hazardous substance. It gets us during use because of the chemical toxicities. it gets us after use because when we throw it away or we put it in the recycle bin, it turns into these particles called micro and nanoplastics. So I have a little roadmap here. I want to kind of travel through it. I'll try to do it quickly so that you can understand what plastic is. You can be a better advocate and you can protect yourselves and your families. Let's start with who makes plastic. And here's a hint, it's a collaboration. Any ideas of what industries are involved in making plastics? If you think you know, go ahead, put it in the chat. It's a group project. My kids are always like, oh God, it's a group project. So the first you likely know, the first big industry is the fossil fuel industry. These are our friends who have brought us climate collapse, BP, ExxonMobil, Shell. What about the other industry? It is big chemical, and you may not know, but it is the second most powerful industry on the planet. So I want to focus on the big chemical industry. We don't think about big chemical because we don't buy anything directly from it, or not many things. But big chemical's business model, you know, they make chemicals, send them to other producers to incorporate into those products. And even though we don't buy directly from them, we are surrounded by big chemicals products. They're in everything that we use, even the food that we eat. And nobody is watching to make sure these chemicals are safe. And since you guys are political folks, I'll get into a little bit about why this is a little bit later. So if you're a big chemical, how do you make money from this business models? Well, you create new chemical. You tell your chemists, hey, please make me some more new chemicals. So these new chemicals are called novel entities. They are synthesized. They don't appear on the face of the earth. They have never appeared until they are created in a laboratory somewhere. So I recently gave this talk and someone came out, an engineer came up to me afterwards. Oh, wait a minute. How can that be a new chemical every 1.4 seconds? And I thought, yeah, you know, that is kind of weird. How could that be? And so the first thing I did, I went back and checked the statistic, and it is correct. This was what the UN Environment Program stated. And the only way I can figure that this happens is that these processes occur in laboratories. After a series of reactions, you probably get hundreds of thousands of new chemicals created. Weeks go by and the same thing happens again, but the average comes out to a new chemical every 1.4 seconds. And then this study in 2021 shows us that plastic production is driving the production of new chemicals. You can see the rate of increase of the number of new chemicals overall, and the number of new chemicals incorporated into plastic products parallels each other. Notice the name of the study. They give it a really complicated name, outside the safe operating space of the planetary boundary for novel entities. Well, these scientists stated that we have surpassed the planetary boundary for novel entities. You now know that's newly synthesized chemicals. And what this means is that the planet can no longer handle all of these new chemicals, can't absorb them, can't process them, can't break them down. So we have a chemical problem. What are we going to do? Dems are really great at problem solving. Well, in Europe, they came up with a plan to ban thousands of these new chemicals called the Restriction Roadmap. The EU press calls it the Great Detox. But I want you to notice how many of these toxic chemicals are related to food and children's toys. What about us here in the US? We have no plan. Our regulatory system is broken. Nobody is watching. I'll go into that a little bit more later. Few of any of these newly synthesized chemicals are known outside of the industry, and they are not tested or otherwise regulated. I want to introduce you, if you don't already know, the American Chemistry Council. This is the trade group for the plastic industry, and it has fine-tuned the art of cranking out pro-plastic propaganda. Here are some of the greatest hits. And I want you to be familiar with these so you can inoculate yourself from greenwashing, is what the commonly used term. I would call it fraud or outright lying. So what is plastic? Now that you know the players, you likely know what plastic's made out of. Two big sets of ingredients. We got the fossil fuels and we got the chemicals, right? The fossil fuels are made into hydrocarbon polymers. What's a hydrocarbon? You may remember from your high school chemistry, it's a molecule with only hydrogen and carbon atoms and a fuel that combusts in the presence of oxygen and heat. Here are some basic hydrocarbon monomers that are used to make plastic. Notice they only differ by the number of carbons in the backbone. They are made into polymers in large, heavily polluting refineries. Polymer, because you'll hear this a lot now, is just simply a large molecule of repeating units. How you make that polymer, I like to use the analogy of stringing beads together to make a necklace. This is ethane being made into polyethylene. And here are the other plastic polymers, propane into polypropylene, styrene into polystyrene, which is styrofoam. And there's one more ingredient, of course, and this is really a trade secret. This is what, but it's starting to get out now with all the studies. You're starting to read about this in the newspaper. You can't make plastic just from the polymer alone. You have to add chemicals, and lots of them, more than 10,000 chemicals. And you might think that's kind of weird, 10,000? Did I just like make it up? Kind of a weird number. It came from this study, this 2021 study that knocked the socks off of plastic scientists around the world. I mean, we knew there were a lot of chemicals that were used to make plastic, but we didn't know there were 10,000 of them. So why do we need all those chemicals? Because the chemicals provide different functional characteristics to plastic. They give plastic its miracle qualities. Here's just an example. We have plasticizers that make the plastic look pretty, that make it functional, provide coatings, make sure they don't catch fire because they are made out of fossil fuels, stabilize them in heat and light exposure. And then most importantly, there's a huge class of chemicals that are merely used to enable the mass production of these products. So like the plastic polymer goop doesn't stick to the machinery, for example. Okay, so why is this important? Why is it a big deal? It seems like these chemicals have all kinds of important functions. Well, it is a big deal because these chemicals are persistent organic pollutants and heavy metals. And let's start with the persistent organic pollutant. What is it? It's persistent. That means it's oily. Picture an oily chemical in that we call it hydrophobic. It resists water, which means it can't be broken down. You know, oil and water don't mix. It doesn't break down in the environment. It can't be eliminated from our bodies. You know, we eliminate pee and poop are basically water-based elimination processes. So we can't get these chemicals out of our body. And that's why organic in this context only simply means it contains at least one carbon atom, and it's a pollutant. These chemicals accumulate because we can't rid them from our bodies. They accumulate over time. And this happens in people. And they don't just sit in our body. We store them in our fatty tissues, right? They're lipophilic, fat-loving. And then they begin to interfere with our cell function and bodily systems. And I'll show you how in a few minutes. So, and what's a heavy metal? That's the other type of chemical that's used to make plastic. The definition, it's you know, an element from a certain area of the periodic table that has certain properties that define it as a metal or a metalloid. They're toxic, and they have either a high density, either with a high atomic number or a high atomic weight. The first you're likely familiar with is lead. And thank you, this came from Nalini, who just sent me this. I think it was yesterday from the CDC. You know, I'm 65. I breathed in a lot of lead from gasoline, combusted gasoline, and I thought that was such a victory. We got lead out of gasoline, but it's still around and it's still causing the same kinds of harms from the CDC website, courtesy of Nalini. We got mercury used to make plastic. We have chromium used to make plastic. And we have one you likely have not heard of, is antimony. This is used to make our plastic water bottles or PET plastics. So to recap, we have plastics made from fossil fuels, which is itself a persistent organic pollutant. And then we have this whole other group of chemicals. So what happens when food or water contacts plastic, right? The plastic industry would convince us nothing happens, right? So we look at the water bottle study. We get this from the Netherlands. They set out to test these. These are reusable plastic water bottles, squeezy. And they had 2 new ones, 2 used ones of brand A, 2 used brands B, and they have a control group of glass bottles. And they filled these bottles with ordinary tap water, let it set at room temperature for 24 hours, and then tested the water to see what was in it. And they found over 400 plastic chemicals had migrated from the bottle into the water, and this is after just 24 hours, room temperature. So then they took the bottles and put them through the dishwasher, as we likely would, with reusable plastics. And they took out the bottles after the dishwasher cycle, rinsed them really well, and then repeated the experiment, filled them with ordinary tap water, let it set 24 hours, and this was all at room temperature. And this time they found 3,500 chemicals. So notice we go from 400 chemicals before the dishwashing to 3,500 chemicals after the dishwashing. So what's this study tell us? It tells us that plastics leak chemicals fast. It was only 24 hours. We've got food and water sitting around in plastics in distribution warehouses and in our own fridge for a lot longer. Plastics leak chemicals. We're talking about new plastics leak chemicals, old plastics leak chemicals. They leach at room temperature, and they leach into pH neutral substances like water. And we also learned, this is really, really important, weathered plastics leak more chemicals than new plastics, right? We had, what did the weathering? It was the dishwashing cycle, the heat and the agitation from the water. We went from 400 plastic chemicals to over 3,500 after a dishwashing cycle. So what does this mean? Let's apply it to our daily life. It means that reusable plastics leak more chemicals than single-use plastics. It's really, really important. Not that single-use plastics are great, they also leak chemicals. It's just that reusable plastics leak more and faster. So plastic chemicals are mobile, and plastic, I hope you've concluded, is a horrible food contact material. How does this harm us? We talk about some chemical, let's look at chemical exposures first. I have this chart, I'm going to move through it really quickly. Let's look at our plasticizers. We have bisphenols and phthalates. I call these revolving door chemicals because, you know, we actually do pee them out. If you check urine of everybody that's here, you'll find bisphenols and phthalates. We do, our body is able to eliminate them. But there are so many, these are called everywhere chemicals. There's so many bisphenols and phthalates surrounding us that as soon as we eliminate them, we take in new ones. So that's why I call them revolving door chemicals. Bisphenols make plastics hard, and phthalates make them soft. And please note that these are huge chemical groups. 200 bisphenols, there's not just bisphenol A. I'll touch on that in just a minute. Then we have this other huge chemical group, plastic coatings. These are the PFASs that you've likely heard a lot about. I want to point out there's over 10,000 PFASs. These make things slippery. They coat cookware, that's your Teflon, Scotch Guard, outerwear. We put them on textiles, and they're in our food packaging. Flame retardants, why do we need these? Because our plastics are made out of fossil fuels. We don't want them to spontaneously combust. And all of these are persistent organic pollutants that cause a wide range of problems, health effects. You hear them referred to as endocrine disruption, endocrine disrupting chemicals. I really hate that term because it's so reductionist and it's kind of abstract. People just don't connect with that at all. And I'll come back to a better way to talk about those chemicals. And then finally, we have the heavy metals, impacts on children and youth. Now, here's how I want you to remember these noxious chemicals. These, and I took liberties with the word noxious, and it's neurotoxins. They harm our brain and our development. They're obesogens. They mess with our ability to regulate energy, store fat, process our cholesterol. They lead to cardiovascular problems, and then they're carcinogens. So these chemicals are noxious, and here's a way you can remember it. It's noxious, N-O-C. So you're asking, why is this permitted? You know, don't we have an EPA? Don't we have an FDA? What the heck is going on here? Well, let me show you what's going on. It's because of our regulatory model. In the US, we have the personal risk regulatory model, where the rest of the world uses a general hazard regulatory model. And you're political folks, and so I want you to understand this. Here in the US, the EPA and the FDA are permitted to regulate one chemical at a time, and the rest of the world, whole chemical groups. Why is that important? Here's why it's important. I bought this for my kids, you know, a couple years ago when they were doing sports, and I thought, oh, good, it's a safe way for them to take plastic, or, you know, fill the whole thing with filtered water, and then they can take it to their events, share it with their kids. They won't have to use single-use plastic bottles. And there was a BPA-free sticker on it, and I'm thinking, we're good. But what I didn't know at the time is that there's more than 200 bisphenols. And that we have what's called now the regrettable substitution. So this jug that I had, that my kids use, did not have BPA. What it likely had was BPA, BPS, or BPF, or BPB. There's all kinds. And a lot of these bisphenols are worse than BPA. That's what happens in this country when we don't ban whole classes of chemicals. We get this whack-a-mole thing with industry. Here's the other, let's go through our chart. The other reason we can't regulate anything in this country is because the burden of proof. In this country, the burden of proof is on our government to prove a chemical is wrong. Everywhere else in the world, the burden of proof is on industry to show that the chemical is not harmful. So what does this look like? Here's the United States. Hey, we're hearing that a new PFAS is showing up in people's blood in California. Are you guys making a new PFAS chemical? This comes from our government. Here's the industry. Oh, yeah, that one. We came up with that a couple of years ago. Our study has shown it's good, and it's a really hot seller. That's what goes on in this country. Here's the flip model in other countries. The industry has to contact government. Hey, we came up with a new PFAS chemical. Can we sell it? The government responds, no. So my kids like to say, no. Let's see your data. And we'll have to test it too, because we already know that PFASs are bad. Also, here's the other problem, technicality. In this country, there's a really high bar to prove that a chemical is bad. The government has to prove that the chemical causes a specific disease in humans. That's the personal risk regulatory model. The other models, all of the government, all the industry and government together have to show that the evidence that the chemical does not cause harm. Generally, there's no evidence, or very little evidence, that the chemical harms humans or the environment. The timing, because the technicality is so complex and the bar is so high here, is very slow. In Europe and Canada, very fast. We're already there with these chemicals, and that's why Europe has put forth this restrictions roadmap, and it hasn't happened yet. We'll see if it happens, but the plan is to ban thousands of these chemicals, including whole PFASs and bisphenols and phthalate groups. This is a great article if you really want to understand better why our regulatory system is broken. It was set out very clearly in this article. Oh, what about PFAS, you ask, right? We've been hearing all about PFAS, right? EPA is going to ban PFAS. No, EPA is thinking about banning 6 of the 10,000 PFAS chemicals only in drinking water. And here's a huge PFAS risk to our kids, I think, especially this packaging. In California, individual states are taking this on. And California has done this. Oregon just passed a bill. Washington passed a bill. But you got to keep an eye on these bills. There's a lot of loopholes. There's a lot of restrictions. So if you're interested in this area, it's something to investigate. So how does it harm us? We look at chemical exposures. We've already looked at chemical exposures. So now we're going to look at particle damage. So we know now that wherever plastic ends up, it breaks. We're describing these microplastic. It's technically a plastic fragment smaller than 5 millimeters. Unfortunately, that just keeps breaking into smaller and smaller pieces. It becomes microscopic, and now we're describing nanoplastics. That's a plastic fragment smaller than 1 micrometer or 1/8 the size of a red blood cell, and then nanoplastics continue to break. So now we have this whole range of plastics sizes, and it's really a process. Scientists call them MNPs to describe the whole range. And like other kinds of pollution, these MNPs spread everywhere. And they're in the water. Every water source that has been tested contains micronanoplastics. These are the most common types of plastics found in water. I mentioned the microfiber bill to Assemblyperson Holden. That is before the California legislature right now require filters and washing machines to at least pull out the microfibers. And this is important because microfibers are the most common microfiber found in the environment. They're in the air. How they get in the air? They're kicked up on the ground by traffic and other things, and 20%, this was at least in 2020, there may be more data on this now that's a little bit different. At that time, 20% was kicked up by sea spray into the air. Recent study, scientists tried to measure how much microplastics were dropping out of the air in Auckland, New Zealand, and they measured the number of microplastics on rooftops in Auckland, and then they extrapolated and found that the equivalent of 3 million plastic bottles worth of plastics were falling on Auckland each year. And this is the type of plastics that were found there in the air that we're all breathing. And it's knowing micronanoplastics, and again, the most common types. Now, I know this is really depressing, but please hang with me because it gets really fun and exciting soon. But one more area to look at is the soil. This one just kills me. I don't know why. It's just creepier to me than the other ones. So our soil is teeming with microplastics. They drop out of the air into the soil, and then there's these plastic-intensive farming methods. And I do want to point this out to you because you have some control complaint to your nursery. These slow-release fertilizers are actually little plastic balls, and as they break into microplastics, the fertilizers release into the soil, so you're contaminating your soil. Why is that important? Because this is killing keystone species at the base of the food web of our food supply. We already have really good data that these micronanoplastics are killing earthworms and beneficial fungi, bacteria, and other organisms in the soil. Same thing's happening in the aquatic food web, and this is why the microfiber legislation in California is so important. That's Assembly Bill 1628. So there's really good data about how these plastics are killing zooplankton, which is at the base of the aquatic food web in both freshwater and marine water, the ocean. So we're eating and drinking micronanoplastics. They've been found in every food that's tested, which means we're also eating all those chemicals. And we're finding them in our body. In, again, every place that's been tested, we're finding them. And so what happens when they get into our bodies? We're looking at different sources. Scientists are looking at different sources now to figure that out. And scientists have begun to conclude there's two different mechanisms of harm here. The first is mechanical damage from the particles themselves. You can see because these are broken fragments, and the other thing you see here is a microfiber. You can physically damage the tissues and cell membranes. An example of this was a recent study just a couple months ago, how baby seabirds are ingesting plastic and just scraping up and causing scar tissue in their digestive tract. And if it happens to seabirds, it's happening to us too. And then they also poison us, and now you say, of course they do. They're made out of 10,000 chemicals, right? And not only are the plastics made of chemicals that they then start to leak once they get inside our bodies, because they're lipophilic, they also attract other lipophilic chemicals that are in the environment, pollutants that are already there, benzene and other things. And then when they get into our bodies, they release them. So what happens to plastic? We looked at this earlier. Let's get into it. I like to start with incineration. It's pretty clear. We know that incineration is just the transforming of matter from one kind to the next to an air pollutant that is then spread over a large area. It's just a sneaky form of dumping in my book. And in terms of what we send to the global south, a lot of it's openly burned. Then the landfill environment issue, we don't have good data. How much is actually going to landfill? How much is going to environment? Nobody really knows. But we know that no matter where it ends up, you now know, you're the plastic experts, that it ends up as micro nanoplastics. And I also want to remind people that the landfill itself is also the environment, and we're beginning to find these things in the leachate. It's contaminating groundwater and our soil, another source. And then let's get into this issue, and hopefully you're asking yourselves, why only 9% of plastic ever produced has been recycled? What is the issue? Well, it has to do with the definition of recycling, and so this is key. The recycling is the process of converting a used product into a new product of equal or better quality. So the industry finesses this. I want to show you how plastic is produced. Just bear with me here. You can see that these pellets, these are pre-production pellets. We call them granules here because this, I think, came from Australia or England. We call them pre-production pellets or nurdles. They're fed into the hopper, they're melted, and then they're squeezed into a mold. Let's say this is a Lego. And you can see, and then it cools, and then voila, you have your, let's say, green Lego piece. Let's see if I can go on here. Okay, stop now. Great. Right. So what we would like to do is take that green Lego, please, grind it up right, put it back to the hopper, make another one. When people think of recycling, this is what we think we're doing. When industry says, when Coca-Cola says, we're recycling 100% of our plastic bottles, this is what you think Coke is doing, right? They're taking the bottle that you've just used, they're putting it back through the machine, and they're making another one. That's what people think. But that can't be done because you can see that when the granules are fed through this screw, they're heated and they're squeezed into the mold. And when you do this, you irreversibly damage that polymer. Remember that polymer that we looked at the beginning of this talk? And it's not just me saying so. This comes from a chemical engineer in one of their journals. Now, I want you to think about this. If you make bread, this is like over kneading bread. Once you've over kneaded the bread, there's no going back. There's nothing you can do. Same thing happens when you use Play-Doh. That's, again, heat and compression. And you remember that after you play with Play-Doh, it becomes kind of crumbly, it falls apart, and you can't go back. So what can we do with used plastic? You can downcycle it one time. Only some plastics, PET plastic is one example. PET plastic, you can one time make it into a product of inferior quality, like a plastic bag, and then it goes to the landfill. And the thing is, the bag is not in demand. Because it's a product that's not in demand, it does nothing to displace plastic demand. You can do this fancy thing like with your Play-Doh. You got this old crumbly Play-Doh. If you take a little bit of the old Play-Doh and you mix it with a bunch of the new Play-Doh, you can make something, again, this is how we create post-consumer content products. A whole lot of virgin plastic, a little bit of the old plastic. The plastic industry loves this. Gives an excuse to keep using more plastic but appear green. And then somebody had the bright idea, hey, let's burn it and try to make the waste into something useful. And beware, because this is coming to a facility near you. First, we have the energy recycling. We can burn that plastic and recover the fossil fuels, right? Wrong. The only thing that's ever been recovered is a low-grade oil that nobody wants. And, I just talked to, there's a guy in Sonoma County, I actually was down there about a month ago. He has venture capitalists putting a bunch of money into one of these facilities to do this. It's called advanced recycling. And so it's coming to a neighborhood near you. I want you to know the arguments why this is not a good thing. Then someone said, hey, we can burn it and recover some of those monomers. Remember those monomers? The building blocks and maybe some other chemicals. And this has never been realized. This is purely aspirational or theoretical. So I have my little icon here, the cloud and the brain. Meanwhile, these facilities are burning plastics and they aren't being regulated because they're classified as manufacturing industries, not incinerators. So even incinerators aren't regulated very well, but they're definitely regulated better than these so-called manufacturing facilities. So what do these symbols mean to you? You remember, if you're my age, you might remember that in the 1970s, it's the plastic industry who invented these symbols. And your lovely state of California is in the early stages of a lawsuit against ExxonMobil for false and misleading advertising, the advertising being these recycling symbols. So bottom line, plastic is not recyclable for two reasons. Number one, the heat and compression damage the polymer. You can never recreate the same product again. Number two, and you probably guessed it because I hope that you're now plastics experts, there are thousands of chemicals that are contaminating the plastic mixture. And you've also learned that weathered plastic leak more chemicals. So if you try to put chemicals back, let's say like you probably, and I did this too until I learned all this, I would always try to buy the post-consumer content product, right? Thinking I'm being more green, I'm helping the planet. It's incredibly toxic because any post-consumer content plastic has been put through 2 production cycles, very weathered, very leaky. Recent study that looked particularly at recycled PET bottles in Europe and found the same thing. They leak more chemicals than virgin PET bottles. And then this is the worst. Don't use black plastic because it contains recycled e-waste. And that contains the outlawed brominated flame retardants, because they were outlawed because they're so toxic, but they're still present in these products because, as you probably likely have guessed, the plastics industry is a global industry. So these products are likely made somewhere else and then shipped into the United States. They contain antimony and lead, among other things. So what can we do? That's the depressing news. Let's get to the really exciting, great news because there's lots of, and Dems are so good at finding solutions. Great. I'm proud to be in the tradition of activists. We have your downstream solutions. We have your upstream solutions. So let's look first at the downstream solutions. Are there any good ones? Well, first let's look at the false solutions. Recycling, as you've just learned. Every day I get emails from people, hey, did you read about the plastic-eating bacteria, enzyme, worm, or fungi? I'm going to tell you that even if this were more than something that's happening in a laboratory somewhere, and that's what's going on at this point, there's no way you could scale this up to take care of the billions of plastics that already exist and that are being created. And then there's the compostable or biodegradable plastic. First of all, biodegradable plastic is just plastic that breaks into microplastics faster. Compostable is not really compostable. It has to go, you won't compost in your home compost or a municipal composters. LA just passed a law saying, hey, we don't want this stuff in our municipal composting anymore. Because as you might guess, it's also made out of the same toxic chemicals that conventional plastics are made out of. Who wants that in their compost? Let's look at true solutions. Here's a downstream: river, beach, and community cleanups. And why do I think they're a good downstream solution? Because they educate people, they inform people. They show people how outrageous this problem is, and they get the river and the beach cleanups, get the microplastics out of the water. They help us actually probably save entanglement and suffocation harms for aquatic animals, and they retrieve the plastics before they start to break down and then become irretrievable. And the most effective, though, beach cleanup uses the data in a specific way called the cafeteria culture way or method. These are the way the students set out their beach plastics in microplastic mantas, and look how powerful this is. So this connects with people. I was talking with the river group in Missouri, and they're like, yeah, we pulled a refrigerator out of the water and a sofa out of the water. We took pictures and we told everybody about it. And it's like, well, that doesn't get people to think about plastics or, I mean, because I think what happens is you're thinking, I'm not the kind of person that would throw a refrigerator in a river. That's just some other weird kind of person. But when you see the single-use plastic set out like this, people connect with it. So it's really important the way that data is presented and organized. So now how about upstream solutions, right? It's very clear, I hope, after this presentation that we have to turn off the tap of plastic production. And you're going to ask, well, how? I mean, it just seems so big. We start with thinking differently about plastic. I bet after my presentation, you've already started thinking differently about plastic. And this is an example I like to use. So here you can go to your grocery store and here's your choice. And notice both of these bottles have 14 ounces. Aside from that, the plastic bottle has all these wonderful conveniences and it's cheaper. If you have the privilege of choosing the more expensive and the heavier item, please do so. Many people don't have that privilege. Thinking differently about plastic results in action. So the Canadian government classified plastic as a hazardous substance in 2021. And in 2022, they began to phase out single-use plastics. Where do you start? I send everyone to this. I use this framework a lot, not only for my personal way of looking at the world, but this is really great when you're talking to your legislator or your organization there. I saw that there was a barbecue coming up. I bet there's going to be plastic foodware. So you can ask yourself, you can use this framework to figure out maybe what you don't need for that barbecue. So this is the framework that was used to phase out chlorofluorocarbons in the 1980s. I know it's a mouthful. Do you remember that? Scientists were finding these increasing ozone holes over both of the North and South Pole. And the problem was that really important products contain these chemicals, refrigerants, propellants, and we just really didn't have any substitutes, at least for the refrigerants at that time. So they came up with this framework, and they first looked at which of these products are not essential. Let's get rid of those first. Which of these products do we have substitutes for? Let's get rid of those. And then finally, you have the essential products. That's where science needs to be focused. We now have the AI for better or worse. Why don't we use it for better and start coming up with some substitutes and alternatives for, these are like medical applications, our cell phones, this computer, many things around us are plastic that we really don't have any substitutes for at this time. We need to change the way we eat. I hope it's really clear to you that plastic is like the worst food contact, well, one of the worst food contact materials that we could choose. I would start by screening microplastic madness because it teaches people about plastics and it's hopeful and engaging and inspiring. And again, and I'll show this QR code at the very end. You can point your camera here. This is a preview link for your personal preview. If you want to screen it in a larger venue, please contact me. We've had folks everywhere hold big screenings of this movie and then engage in action. We've had theaters, we've had Rotary clubs, libraries, aquarium schools, you name it. Individuals like you have just said, you know, I got to do something about this. They've held a screening. They've invited people. People's eyes are, oh my God, I had no idea. And then people take action. You can try Plastic-Free Lunch Day. This comes out of cafeteria culture as well. We do it twice a year with the Urban School Food Alliance and cafeterias, hundreds of cafeterias across the country. There's an entry point for all schools. You can, maybe it's you can only like get rid of straws for one day. Some schools are there. That's all they can do, especially in some of the red states that have preemption bans. They have laws to ban laws for phasing out or banning plastics. Fortunately, it's not Oregon or California. A lot of the schools, particularly in California, are way beyond this. Many of them can have a full lunchtime and get rid of all single-use plastics for one day. It sounds like a dumb thing, a small thing. It leads to big action, gets people to envision what change looks like. You get some great data to collect and advocate with. Here's a before of a PS15 in a marginalized community in New York City. Look at how the kids have organized their data here and then photographed it. It's really interesting, right? This is what happened on Plastic-Free Lunch Day. They repeated their plastic waste audit. We can tell you how to do that, give you some instructions, and voila. But I do want to point out, look at the school lunch where there was some control over what was being offered versus the home lunch. You know, the kids went home with a flyer trying to educate parents, but notice all the plastics that came out of home lunch. A lot of work a lot of opportunity and work that can be done there. So California, a lot of your schools, they're ready to get rid of all plastics and just switch back to the good old-fashioned reusable foodware like I grew up with, and you likely grew up with. 2 amazing plastic-free restaurants out of LA has money. Well, just give schools money to buy reusables. This is a beautiful stainless tray that's being used by a lot of schools now. We know the vendors. HIMSA is a vendor. Plastic-free restaurants will give your schools money to do this. And Center for Environmental Health, a very, very good friend, a dear man, Ben Schleifer, will help you do this. So please contact me if you know a school that's ready to do this. We need to reinvest and rebuild our schools, and that is California. So I was trying to explain earlier, has money. If your school needs a dishwasher, you know, they're really expensive. They're thousands, tens of thousands. But in a lot of these schools, it's $20,000, $30,000, $40,000 just to install them, depending on what the infrastructure. California has money for this. You can join the real food movement. Plastic and the way we treat food is intimately connected. Most of the food that's associated with plastic are low nutritional junk food, highly processed. So farm to school is another way to make a difference here. And I want you to notice in the farm to school there with First Lady Newsom, they're using paper boats lined with plastic. So we got to get those out of the schools. Contact your water groups. This is Nalini joined me about a week ago for this talk. River groups and water groups are already picking up their plastics, but they're not organizing the data well. They got to take those plastics, set them out, and do a better job with the data. Forests. I'm such a tree lover. I know you all are too. Forests, here's a place to do action. Plant trees in your own yard. Support your forest and your state parks or friends of state park or natural environment areas. Trees, there's some data about especially the large conifers. We have duck firs up here. Their needles are sticky and they collect or particulate matter from like exhaust. So they likely do the same with micro nanoplastics. Collect your data and advocate by using our movie or anything else. But thank you.